Okay, guys, so we are back again. As you could see, this looks pretty fine. There are some small tweaks which I would like to show you. The one is we have this 180-degree rotation inside, which was not meant by me to do so. So therefore, you can see that at the home position, we have this feature on the screen in the bottom, which is here in the robot. This is a quite good reference point because we can see this. And if I click here the workpiece _0 feature, then you can see, okay, it turns 180 degrees. So what we should do in this case, we just have to check out the coordinate system of the workpiece frame. So first, I will just hide all of the other features which we don't need, that we can see the one feature what we need. So this is the workpiece feature, and you can see that the Z coordinate is the turning axis what we want to use for. But we never change anything on the frame because this is hopefully one time correctly measured. So we are coming to our workpiece _0 feature. And here we want to turn it around 180 degrees along the x-axis. And this is what we have done. And right now, you can see on the screen that this really stays in the same orientation. This might happen based on your configuration, based on your setup with different kind of angles, or experiences that you should step away always 45 degrees, so 0, 45, 90, and so on, and you will find the right position. So this is our recommendation. In my particular case, this was very easy to see with this 180 degrees. Another stuff what I would like to show you, and that we should copy the configuration from our recorded points to this workpiece _0 target. And how we do this? So first, we have to select one of our targets. It doesn't matter which one. If everything which TP1 to 6, this is everything which we recorded by the pen. So one of these would do the job. I just select the P4 and or just for this example, I select the P3 and I activate this tool. Okay, so the P3, TP3 is the active TCP at the moment. So I double click the home position. I one time click with the left mouse button, the workpiece, right click on the workpiece and teach current position. Okay, so that's all. From this point onwards, you have the configuration for everything what we recorded with the teach pen. So this will follow exactly the line, and the head, the flange of the robot is turned exactly the same rotation what we want to have intentionally. So the last stuff what I have to do here, I will double click here in RobotDK, and I just test out if the robot moves the same way I expect, and it does. This is a very good stuff for us. I just rename it here, and I just make _2 here at the end, and I just transfer it again to the robot. Send program to robot. It's done. I'm just coming to the teach panel, and I try to make it to do so that you can see clear edit. And this is the _2 script, the new one. Exit. I reduce the speed. Safety first. And here we can see hopefully what happens. And right now everything will move around as expected. Okay, I crank up the speed. Balázs, maybe you can capture this. So right now with full speed, the whole story, and then we are coming a little bit nearer to the reality, what we want to reach. And The last stuff which I would like to show you, thanks for Barrage, we have a couple of afterwork tools for the remote TCP. And the most important, most probably, might be if you have a kind of offset, what you want to fix out. So I would like to show you how we can do this. I just make here everything visible, all the TCPs on my screen again. And we just open up the Easy Automator Afterwork Tools set. And here you can find for the Remote TCP, all the tools which we have for the Remote TCP, they are called Remote TCP. How it works exactly the same as with the normal one. But if you change them up, if you mess it up, it can be fatal. So therefore, we just rename them Remote TCP, and then you can find the correct way how to do this. I will use the relocate and rotate waypoints. I just double click it. And once the license is verified, then you can see here on my screen, you have exactly the same stuff what you could use for the normal operation as well. Here, I want to point out, if we are talking about the frame, then I think we are talking about the flange of the robot. And if we are talking about the tool, then we are talking about the workpiece. So in this case, I will use the tool. And I would like to apply it to each point, which we already captured. So get selected point. I don't want to change the orientation, therefore the rotation center is the selected target, so I don't want to change on this anything. And the offset might be, in my particular case, just check this out. So the Z is showing to this direction. I would like to use additional 10 millimeters on the Z. You know what? I just check out the program. Let's use, okay, just stick to the Z. I don't want to crash the robot at this moment. Just use 10 millimeters additional. So my expectation is that we will shift everything 10 millimeters into this direction, and we will get an even bigger offset to the tip what we had before. So I just hit execute, and if I do so, I would expect that all of the points will be relocated to this direction, which was happened. And I just renamed the program here to _3. I just transfer it to the robot again. And we just changed to the microphone on the cell phone because the other cam gone out. So I just try to speak a little bit louder. I just read in again the new created script. And then we just see with a lower speed that the offset should be even more so far away from the tip. And you could see I made my first mistake. So this was the wrong direction. I would have to use the +10 direction. I was just coming to even more to the tip. This was a problem. So I have had to use the other direction to move far away. So therefore, this is even more important that you always test it with a slower speed.